Mhm. And we want to give you more information about this new profession on the market. And this is really like story. I want to tell you my story at first, before I will introduce our school. For example, every person have a dream. My story is like this black screen IT give me a reason why I should change my life a little bit. I change a country for living, change my work, and now I really feel happy. So I want everyone have their dreams come true, and maybe it will be so nice if we will help you with this. So let me introduce you our school. About our school. The project of the IT school programming in Silicon Valley for English-speaking students. Founded in 2016 in California. Instructors and assistants work in companies in the USA, Canada, and Europe. Programs are developed considering the requirements and processes of IT, corporations, and startups. Students undergo internships on commercial projects. We help students to reach employment. Also, we have offline classes, but during the years, we understand that it's more comfortable and when you have classes from home, you can feel more relaxed and you can concentrate better. So that's why now we make online classes. But as you see, also since 2016 year, we have offline classes, and groups was really big. We have too much reviews that you can see on our YouTube channel. People tell how they change their life, how they find new job, and how our company helps them with it. So our students, after our courses, work in really great companies like Tesla, Amazon, Google, Microsoft. And it's really a big chance, is my opinion, because we really give good education. What else? What's the main thing? We also give you projects, because how the education going? At first, of course, it's lections. So you started to understand this program in life. Then you have practice. And after practice, you have project. With this project, you can. It will help you to find a new work easier, because you will have a project. And we're also happy with this. So yesterday and today, we have free live classes. And yesterday with Oksana, you know what is machine learning and how it works. And today, we want to give you information about the power of AI and machine learning. So about machine learning, let's talk about the machine learning industry. It's not just booming, it's just exploding. The global machine learning market size was valued at 8.43 billion in 2021, and is expected to grow by 38.8% a year. So by 2030, it will be like 209.91. So it's really the future of money, of dreams come true, of course. And I think it's the future of programming, as everybody. So 76% of companies prioritize AI and ML over their IT initiatives in 2023. 47 of digitally mature organizations have a defined AI ML strategy in place, and 64 of business I know it's like little business, it's like huge business companies also use AI in their programs. So I want to introduce you, Paul. It will be structure of this course, and I want Paul to tell about himself and also about machine learning.
All right, thank you, Yana. Am I? We'll just stay focused. Is it? Oh, I guess it's got me on here. This is the focus. Okay, perfect. So, I started out sort of dabbling in machine learning and AI in college, because there weren't a lot of opportunities for the types of stuff that just in the last 2 or 3 years has exploded, and become available everywhere, partly because of transformers. And so over the years, I worked at an optoelectronics manufacturer that had a lot of contracts with the military and aerospace. And over the years, I just got to incorporate AI and later machine learning into the workflow there as much as because it was very everything was very custom, every order. So there were a lot of cases where just basic edge detection, vision model type stuff was very, very useful. So I had about a decade of that using Clip came later, but models like YOLO, and using them in a manufacturing context. And then in the last 2 years at Blue Box, I used both LLMs and vision models in various pipelines. They were kind of throwing everything at the wall and seeing what would stick. And so in the last 2 years, I've been able to do things like fine tune. So this is modify after the fact, sort of an aftermarket change. Fine tune a Llama variant. It was a 7B variant for basically for customer support, and it did an early form of function calling. So kind of proud of that. That was before function calling was incorporated into Llama. All right, that pretty much covers everything here.
Mm-hmm.
Do you want to control the slides?
Yeah.
Okay. And it's the same copy that was on Google Drive? Okay, perfect.
Yeah.
So first sort of subsection you guys gave me was AI progress in the past. So go ahead. You could change slides now. There we go.
Yeah.
So you had a list here of it was classification, regression, clustering, anomaly detection, and these actually fit under a couple of different sort of more general categories. So in machine learning, there's supervised learning, there's unsupervised learning. It's not on here, but there's a semi-supervised learning where categories can sort of naturally fall out of a large data set. But basically, the various machine learning tasks here, the one that I've been able to use the most recently that has sort of taken off have been these generative ones. So there's Sora is one that everybody knows about. Obviously, the GPT LLMs, all that's GPT is sort of a cumbersome acronym, but it means generative pre-trained transformer, which is even harder to say. So I guess I understand why they say GPT. But they're also, I think, generative adversarial networks were popular for a while. That was some of the early art models. And just to give everyone a sense of what Dolly, which I believe is not, well, the pipeline isn't public. So it's that model is behind an API, but you might have heard of Stable Diffusion as well. That's another generative model that's started with Stable Diffusion 1.4, and that became available in I want to say late 2022, right before ChatGPT um, went public. So on the right, you'll see this very awkward diagram that doesn't quite make sense. If you look closely at any one part of it, it's like, all right, this key machine learning task, and this is an LLM trying to instruct one type of generative model, trying to instruct or prompt rather another type of generative model. So it's a diffusion model. Actually, I think it's Dolly 3, which, like I said, it's not um, completely public what their pipeline is. It's probably something like a diffusion model. Could be purely a GAN, so a generative adversarial model. By the way, GANs mentioned down at the bottom, that's when you make them fight. So you sort of try to have one model trick another one by generate stuff, and then if a second model is unable to basically distinguish between the generated one and the ground truth example, then that's considered a good generation. Sort of like a CAPTCHA, but it's all happening internally. Supervised learning, just like it says, it's when you've already got categories and already got tags, descriptions. If it's an image data set, you can go with unsupervised use of an image data set by just training a model. Like an example of this would be Deep Dream, was a model that Google had some years ago, and it was very trippy. It would make interesting visuals. There's supervised, there's unsupervised, there's sort of some gray area between them. Recommendation systems usually use embeddings, so we'll go over that later. But anyway, you can go to the next slide. I promise I won't take that much time on every slide. This is I retitled it for you guys, but I kept your images. This is a convolutional neural network. Basically, so a convolution is when one layer of a deep neural network is sort of fully connected to or connected to the subsequent layers. That might not mean anything yet. I don't know how much you guys have gone over stuff, but it's carrying out a mathematical operation called convolution. So you can see, for example, features of, so this is of a car image. So that first set is just very basic, sort of primal, low-level features. And then you're starting to see things that you can kind of recognize, like a wheel well of a car, that sort of thing. And then on the right, all the way over, these are all collections of what are called features. So they can usually be found at some degree of complexity, like a different degree of complexity like that at different layers in the network. Okay, so carry on. Yeah, so this one's full of a whole bunch of stuff, but I'll go through it really quickly. This slide just had a list of these. So it started with Lynette. So that's Jan LeCun, is a very famous, he's one of the sort of godfathers of AI. I guess you'd say, yeah, godfathers of ML, because these are trained. He trained one with CPUs in the 80s. And it was Lynette, named after him, I guess. AlexNet came much later, but it made use of GPUs, which was a big deal. So big advance to have these highly connected compute resources come into play. They just weren't available before then. We just didn't have the tech for it. So then they played around for a few different years with different shapes. So you have a really big fat base. Basically, this is how you're compressing the image by, in this case, just making use of those convolutions. These are all CNNs. YOLO was a slightly different architecture. Oh yeah, ResNet was when like the big boys started to get involved. So Microsoft, and they did some sort of skip basically they were playing around with the architecture and how things, different layers are connected. So it's not quite a traditional CNN. And then you guys listed vision transformers. So I built that one out a little bit by adding this image here on the right. Basically, these are all ways of trying to make use of the model the that came about in, it was like 20, I believe it was 2016 or 17, I think, was the paper Attention is All You Need. And it was the big advance that has subsequently led to the proliferation of all these new models now, which was the invention of the transformer. So it was Attention is All You Need. It was sort of at the time, that title, All You Need, was because there were a lot of papers that it was basically the tail end of a bunch of discoveries about sparsity and what actually needs to be carried along in this particular generative model, what each step needs to get carried along. So how much information needs to be referenced from the prior context. Turns out it's not very much. You can make it very sparse, and you can still have something that intelligently communicates. And then I added down at the bottom there, just because, for the in the interest of completeness, we've got the lava model. There's a whole bunch of vision plus text encoders. I don't have a diagram of it here, but later I think there's one from Microsoft that has a slide. So next slide. So I'll explain that lava one later. So NLP, the other half of what I do. So RNNs and LSTMs. So you'll notice there's a lot of annoying names, because it's a lot of people who were just giving a lot of different things acronyms, and there was no marketing team involved in the chat. GPT is just hard to say. RNN is recurrent neural network. It's sort of they were building on it's not a CNN, where this one has sort of internal loops. And LSTM is that stands for long short term memory, which is, I mean, it's a type of language model, but it's just in many of the early cases, people thought, okay, there's something, you need to have some tokens that are sort of hidden, that are contain some sort of information about the overall text block. And that was just an approach that turned out you don't need that. Transformers do it by just referencing prior context, although there are some future architectures that do cooler stuff. So word embeddings, that's just for semantic search, lookup, that sort of thing. Sequence to sequence, these are all NLP things. Actually, in the prior slide, I mentioned at the very bottom, lava. Lava is sort of a transformer model that is trained in text language, and then later gets a vision encoder put on it. And then it's fine-tuned a bit to understand that too. So it gains most of its world knowledge. Some of these new models, they gain most of their world knowledge from the text side of things. It's like someone stuck in a room, they read all the books in the world, and then they go out and they get an engineering degree, which, it's sort of the visuospatial component wasn't in the books necessarily, or it wasn't all there. What's that question? Oh. So Transformers 2017, Attention is All You Need. That was that paper I mentioned before. So, someone say something? GPT-1, really not much about that to speak of. Really, GPT-2 was when the architecture, the generative pre-trained transformer architecture, was sort of put in the oven for a long, long time. And then out came something that was surprisingly coherent. It was making text. I remember this guy, Nostalgia Braced, had a blog that I followed, and he had an autoresponder bot back in, I think it was 2018. But he, did with GPUs at home. And then I added in here, NeoX20B is sort of one of the early examples of definitely a large language model. I mean, there was GPT-J, but that was trained by the community. So it was just using spare AWS compute during the pandemic. Eleuther AI is a sort of a nerd collective that did it. All right, so semantic embedding. This is interesting. So if there are representations. Usually they're very high dimensional. So this is just implying it's showing it in 2 dimensions and it's implying a 3-dimensional thing. But there's so many more there. But in this case, analogy is something that almost sort of falls out mathematically when you already represent, when you basically train a model to have similar concepts in text appear nearby in some vector space. So the model is going from input text to output vector, and you want to generally have things adjacent if they're similar, similar concepts. It turns out in that space you can shift things over, and so you can have things like the difference between so king minus man plus woman equals queen. Not the potentially, I mean, it gets the concept across, but there's some other interesting examples of this. Like you can visually use this to do things like remove glasses from people and stuff. All right, next. The state of the art. All right. So I really packed this one, but I'll just quickly go over it. Basically, generative AI, it had a slightly different diagram in here, and I just added in bottom left, we've got an art vision example, just generative art models, I guess they call them now. But that was stable diffusion like 1.4. So really 2022 is one of the early ones that couldn't do hands. And that won you'll see the little prize next to it, that won a regular art contest, and it made everyone mad. And I'm sure that was done partly to cause controversy, but yeah. On the right here, I've just got a little code from an audio model. I just wanted, you can't really show a picture of but I just wanted to show that right away there are models you can load on your computer, but that take text and will take tokenized audio crammed together in a context window of a transformer. So the tokenized audio, the transformer is fine-tuned to know what each of those tokens mean and to expound on them, talk about them. It doesn't generate text. As far as I can tell, there's no way to do that it doesn't generate audio. As far as I can tell with that pipeline, there's no way to do that. But it will tell you things like there's 3 different speakers in that audio clip. Like it'll say it. And you can even do a structured output with JSON. So you can, or any other XML, some format. And so you can sort of force it to actually answer your query directly. And just on the right, we had large language models. I just wanted to show like where generative AI sits in this sort of hierarchy, or subsets. But AI, machine learning, I just say AI/ML on a resume. But all right, next. So voice cloning has just taken off. The TTS, text to speech, these are all, you can see this link at the bottom. If you go there, you'll just see all the models that are available. The sort by trending is just, I mean, these updated 4 days ago. I took this screenshot today. So these fish, I've used fish before. I cloned Don LaFontaine's voice, that the fella who he would go in a world at the beginning of commercials in the 2000s. Anyway, it sounds just like him. It's crazy. You could just put a little clip in there. So from just a short sample, I think someone got scammed very publicly out of a very large amount of money, or that's probably happened so many times now, I can't remember a specific example. But I think there was some business case where it was in the millions, maybe. So I should have included that. But anyway, next slide. All right. This is text to image. I should have a closed parentheses on there. Sorry. And these are all generated with Flux, and it's fair use. So we're on the right. actually, I think the middle and right both contain, you know, probably image types that were in the data set. One thing you'll notice, yeah, but they're potentially copyrighted or the characters are, yeah. One thing you'll notice in the middle one, just to the right, is there's sort of a hybrid of Wookiees and um, Ewoks, because they're sort of similar. There's just an amalgam of sort of hairy creatures from Star Wars. So that is definitely something you'll see these models do a lot. Probably also that's the reason why the chainsaw is slightly wonky. But anyway, go to the next slide. Okay, so we all, or many people at least, have probably seen the Sora example here. They've got the prompt in there, but you can get similar quality results right now. So it's only been a year. Sora's public, but you can get similar quality results with a 5B model that you can run with a gaming GPU at home. So I made the jackalope there. I generated that here with my GPU rig that's running in my closet right now. So it's very it very quickly. I mean, you can even fine tune these. Very quickly became available to everyone. You can go to the next one. All right, so this I thought this was interesting, so I left it in. The So all the models such as Claude here, we've got, they all kind of, it has them sort of birthed from GPT-3. That kind of makes sense. Yeah. I mean, yeah, now looking at, I didn't give this one enough attention. It's all you need, attention. But some of these I would debate. But anyway, the point is that a lot of these models, they do, I mean, certainly GPT-2, 3, and 4 followed architecturally. One follows from the other, and I won't claim this directly, but I mean, it's pretty clear that Llama, and maybe they do claim it in the white paper, but Llama, Claude, a lot of these more famous language models now, they all use GPT type architecture, with small modifications, just enough modification to require you to recompile and reinstall the transformers library every time a new cool model is released. But it's all right. It's free, so that's pretty awesome. Well, Claude isn't free, but Llama's free. Llama's amazing. And there's also DeepSeek is not on here, but anyway. Next slide. So I put in some more recent examples of model bias. This is a topic people keep bringing up, is AI danger. And so we got a
We
section.
will send presentation after webinar to people, and they can use these links also.
Perfect. All right. So rather than reading a slide, which you're never supposed to do, and we'll just go to the next one. Oh, cool. So the two diagrams on the left, there wasn't a title on this slide when I got it. So the two diagrams on the left were there. I added this one on the right just to show, it says that it's O3, right? Yeah, it's got O3 here. And it's really scary, some of the results. So I mean, it's hard, like, as far as, it's very expensive, as you'll see later, computationally, energy wise, it's very expensive to use O3, but it ends up costing something similar to like a junior dev. Uh, so if assuming it is as useful as this implies, that cuts out a chunk of the workforce. So pivot to AI. That's good. Yeah. All right. Next slide. This one looked okay, but I mean, it's comparing these two, I guess. Yeah. Um, so, so large vision models, or which I'm assuming you're talking in this case. Yeah, best for multimodal, few shot, large scale tasks. Yeah. Yeah. How would you few shot a convolutional neural net? Um, Basically, the big models are more generally useful for if you don't know what your task is going to be and you don't mind spending more compute. Um, so more, loading it in more VRAM. Then things like Lava and prompt engineering Lava. This is the model Lava, just Llama plus Vision Lava. Yeah. Anyway, prompt engineering that one. So coming up with a few examples and packing them into a conversation, a chat conversation, and then asking after three perfect examples you went and cherry picked of exactly what you want done. Tell me the difference between two images, that sort of thing. That's called few shotting, and it can be expensive because you're packing a bunch more. The more stuff you pack into context, the more expensive subsequent tokens are to generate. But in the moment, you don't have to fine tune a new model for some new task. You can just sort of modify a bigger, more versatile model. So it's a trade-off that you see everywhere, but this is just about vision ones. All right, next. Okay, so I saw this slide was titled Florence 2, and it was talking about Microsoft, and I just added the parentheses, the vision language model part. But basically, I've already talked about this a little bit. It's you take a text trained model and you fine tune it. You can almost think of it as fine tuning the model to think it can correctly interpret, these special tokens that have visual data. That's one way to do it. Actually, in this, yeah, it's got embedding. Okay, this is a visual embedding one, and it encodes it. I don't think it. Oh no, it does. It has location tokens. Okay, good. I think if I'm reading this one properly, it's very similar to Lava, which came later and is downloadable. I think Florence 2 actually also is on Hugging Face. All of these models are on Hugging Face. You can, if you know what GitHub is, Hugging Face is just it's trying to make itself the GitHub of of really anything you can do with PyTorch. And or TensorFlow. So I don't want to just say any one type of model or even neural nets in general. I guess, but it's a repository for code and then also for model files, weights, if you will. All right, next. Segment anything, Sam. I've used this one in the field before for more than one thing. It very incredibly accurately will basically assign I mean, it figures out a boundary, and then these pretty images show you, but it's by pixel. I'm pretty sure it's by pixel. It's assigning a probability of whether it's part of one or another, but region. But it's segmenting pictures. So like I believe the one that Sam, there was maybe a Sam pipeline that actually does tagging, but I saw one that um, would also add text descriptions to each region that is segmented. All right, next. Yeah, so I was just two sources, huggingface.co. You can, this presentation will be available. And then Civet AI, I don't think it's open source. There's another one that's open stable diffusion, something. But Civet AI is a great resource for example, if you want to take stable diffusion, which you can get off Hugging Face. It's and load that model. There's a couple different interfaces for it. You want to take stable diffusion and modify it using what's called a LORA. I noticed there wasn't anything in here about LORAs, but low rank adapters. So really quickly with matrix math, you can sort of represent one matrix in a lower rank version. It's sort of a compressed form. And then this is just training a much smaller model sitting next to a main giant model, training a difference model. So rather than modifying the weights directly, you get to train something much smaller that can fit in your GPU. And if it's lower rank, it's probably much smaller. And so you can download low RAS of or low rank adapters of big foundation models, and those will modify their behavior. So in the case that I was thinking of just now, it was Civet AI has low RAS for corporate logos, corporate looking logos, not like a specific. I mean, they probably do have some for a specific. You could do that with textual embedding, textual inversion. But there's a bunch of ways that you can modify the behavior of a art model. But if you wanted to have something that, given a prompt, would always generate something that looks like some theme, some style. So corporate logo, sort of like corporate logo style. I think it's called corporate Memphis is one of the art styles associated with sort of inoffensive background imagery in big corporations. There's a couple different LORAs for, or there's a bunch of different LORAs for very different tasks. And I remember one that would make things in miniature. So you'd prompt it and it would always make like a, I think it was a stereographic tiny house version of it. So it'd be themed. You could do like, French themed, and it would have the flag and it'd have random baguettes and yeah. But it would always be miniature because you're also loading that LoRa. So it modifies the behavior of an art model beyond what a prompt can do. All right, next. Healthcare. Yeah, these were just slides that seem to be going over sort of the topic, sort of useful areas where AI is being deployed. So hopefully in the very near future, it'll bring down the various costs associated with seeing an entire doctor who had to go to school for all that time, and he might be having a bad day, and there's just all sorts of reasons that incorporating like a vision language model, especially for like cases, extreme poverty where there maybe isn't a doctor available at all. This can be a lot better than nothing because it can, carry all the roughly all the text knowledge that you'd get from a medical degree, or quite a bit more actually. But anyway, so we got basically just segmenting. I mean, these are drawing bounding boxes, probably pretty early stuff, and that's surprisingly accurate. Yeah, 1.00. Yeah, I guess that would have to be something. But anyway, next slide. All right, fraud detection, algorithmic trading, credit scoring. This is not new, but so making use of ML and AI for these things, not new. But some of these generative models, especially the multimodal stuff and then the language models, um, uh, they make taking in unstructured data easier. So if you just have a huge backlog of text, or even like scanned documents, or even not yet scanned, and now you have to go scan them. But there's a very recent, if you really wanted to pour over a case, normally you'd have to, like a important court case, you'd normally have to go through a backlog with using paralegals, and they're very expensive, hired people just going through everything. You could set up a pipeline where like either a local model, if it's like very private information, you don't want to send it to OpenAI. You could set up a pipeline where, for example, you could do entity extraction. That's one of the useful things. So entity extraction is like, what are the legally relevant pieces of information, given this prior context. You could just write a prompt, insert some text, and get a structured data out of that. And so, it can in many cases, and as more and more cases over time, but it can be quite a bit cheaper than hiring a bunch of people. All right, next. Oh yeah, I thought this was funny. They got you can dress people. Um, yeah, it's pretty useful if you can have on a website. You can upload your own picture, and then you can clothe yourself with the product on the website. I mean, that's doing something that otherwise would have required going to a brick and mortar store. So yeah, it's or getting something shipped to you or so. Um, I built a customer service chatbot, and sales forecasting is, I mean, there might be a time series component to that, but that's a more of a finance thing. So looking at unstructured data with language models, that's sort of a umbrella relevant topic here. All right, next. Quality control in manufacturing, supply chain optimization, and robotic process automation. So, I mean, these sort of speak for themselves. I did quality control or quality management. I was a quality manager, but I handled the QMS for a business while also doing a bunch of their IT and in the towards the end a little bit of ML. The areas where, I mean, it's sort of self-evident where a computer vision model could be useful here. I actually have a slide that's coming up that'll maybe be a little more relevant to this. I probably should have just did a drop-in replacement, but that's not, yeah, that's not Baxter, but that's just a robotic arm probably filling something up. But anyway, next slide. Autonomous driving. Okay, so Musk has talked about this a bunch where he's like, oh, you know, we don't even need LiDAR. We can just get as much data as possible, and then we'll train a better neural net each time. And architecture does matter. But if, right now we're in sort of a scaling free for all. So maybe there's something to that. Definitely, it will definitely help with edge cases. Like this new AI will help with edge cases where like you sort of you'd need a little bit of human intuition in order to figure out, if like having to successfully crash, like if given no other option, that sort of thing. Just do it in the safest way possible, or choosing various abstract. People come up with moral conundrums for autonomous driving systems, but like I think that was in the movie I, Robot. So um, sort of the basis of the movie. It's why the guy hated robots, because the robot had made a bad moral decision when it was trying to calculate who would be more likely to survive in a car crash. So predictive maintenance, that one's already implemented. Like I was saying before, there's a lot of these earlier models. There are cases where they were already useful for uh, uh, very specific niche areas, and it's just these new models that have been coming out, the transformers, that are very general and can be used for all sorts of things. Um, and yeah, driver mod, yeah, both of those kind of apply to each other. So next. So I think I already talked about the impersonation threat, because there was someone, a lot of money that so quantum threats, I thought that was funny. I left that in there, even though it's, the capitalization is interesting in this page. But quantum threats, um, basically cryptography might go out the window. It's kind of always on the horizon, the possibility that someone would make a quantum computer and then be able to implement Shor's algorithm, which would break, you'll notice in your browser, you'll see it just to the left of the URL, there's a little lock. And that means that you have TLS, you have your session on your browser is encrypted point to point between you and the server. So like a person in the middle can't get much useful data. That would all go out the window um, if someone correctly or successfully implemented Shor's algorithm on a quantum computer. Let's see, proliferation of self-driving cars. That was already. Oh yeah, unified models. Okay, so yeah, this is in the near future. I mean, there are already a couple of different any-to-any models available on Hugging Face. I think the hope, and this still might turn out to be true, but I think the hope with those models. So this is any input to any output. Um, the hope was that as you had a sort of greater sensory inputs and communication outputs for these generative models, that they'd get a better like worldview as you train them on that, because you have to train them on input that's also multimodal, and presumably their output is also multimodal. And sometimes it helps. There's definitely there's a vision model. It had the name of some two-faced Greek god or something, got some figure from mythology, but I don't remember what Janus or something. But it was a model that both generated and did sort of vision language. So it would describe things, and then you could ask it to make things. It saves room to have that. You don't have to unload the model and load another one. And a lot of the components internally are shared between those two pipelines. Oh yeah, personalized marketing strategies, that can get very creepy, because everybody has that experience now of talking about something and then you see an ad for it. As more and more information about us is sort of determined and logged on some database somewhere, you'll get a better model of you, different sense of model, but model of you forming on some server, and then potentially you can be manipulated through very targeted advertising, like generating pictures of things that you care about. That's sort of, yeah. All right, so next. Oh yeah, I put DeepSeek in there because I think the slide originally mentioned foundation models. So DeepSeek was trained for like $5 million, which sounds like a lot for a model that's on par though with GPT-4. That's nothing. The GPT-4 was trained for quite a bit more than that. So DeepSeek was, and I believe it was trained in the midst of the embargo or the limitations placed on GPUs in China, like NVIDIA GPUs. And so they're using other GPUs, or they're just using what's available, and it's still rivaling some of the best models now. And you can download DeepSeek, which is pretty wild. Although running inference, you'd need like 6, or if you quantize it a bit, so shrink the model down, it surprisingly doesn't lose very much intelligence when you go down to like of these big models. When you shrink the weights, the representation of the weights down, it with if you quantize it, you could probably run it on about, I'd say like $25,000-$30,000 worth of GPUs. So, all right, competitive landscape. Yeah, that was just a list of a lot of the companies involved. Quantum computing caution, always 15 plus years away. But now it seems more like, it's going to be always 3 to 5 years away, which that feels like it got closer. So part of the reason is this technology helps in the design of some of these systems, the flux qubits that Google's using, D-Wave built on, all these things. All right, simulated annealing is that stuff. All right, next slide. I think we're almost done here. Oh yeah, fission. I remember it said fusion, but it is. We're hoping fusion in the near future, but that's another thing that's always 3 to 5 to 15 years away. 3 Mile Island is getting turned back on. That is not a fusion plant. That is a fission plant. And I'm hoping the reactor that failed is not the one. A couple of them were just sort of mothballed, and so I think that's happening, partly because of what you can see there on the left, which is just how much using a lot of these bigger models, how it costs a surprising amount of energy. And then I saw brain computer interface was mentioned, or was the next one down there. So those are coming. Those are Neuralink. Part of the reason that Musk is pushing that is because I think he thinks that that's the way to compete with the AI in the sort of AGI future. And then I thought this was great. I left this in. There's a Mustafa Suleiman. He wrote. It'll come to me. It's a great book, The Coming Wave. Great book, still great book. I think it mentioned llama at the end. I thought my grandfather told me about The Coming Wave, and I was like, oh, there's a book already on this AI stuff. I was like, this was 2023, and I remember I read it in a couple days, and I was like, feels like the book must be hot off the press because it's talking about stuff. I mean, now it's outdated by about a year, but anyway, if you get the chance, great book. Next slide. So this is just an example slide from something I'm working on with another company. I don't mention the company in here, do I? Good, yeah. So this was just a presentation I did. If you just hit the little red arrow there, just click that really quick, it can show you. There's basically the little red arrow right there.
This one?
Yes, right there. So that's just showing a 3D model extrapolated from a 2D, just a 2-image input. And then I skinned it with a little camo. So, and it's taken directly from that photo on the left. So that's a data set that, yeah, I could go into it. It's called the flat and fold data set. It's for doing textiles. Next slide.
All
right.
Thank you, Paul. It was really so informative webinar, really a lot of detailed and useful information. I think everybody was excited because some interesting things that I, for example, don't know before. Thank you. And I understand that people have different goals when they decide to visit our webinar. And as I understand from your work, from your stories, that now AI destroyed all borders in different areas. For example, if you have a base with AI, you can work in different areas. For example, healthcare, your own business, finance, everything. So many ways open to realize yourself, and it's really nice base for future comfortable life. Who can become an ML engineer? Gender and age do not matter. Basic education doesn't matter. Detail-oriented invalids, hardworking and capable of learning, able to establish cause and effect relationships and seek new solutions to the given problem. Those who can work in a team. Because in big companies, of course, teamwork, and if you're a team player, you can grow faster. Everybody knows. So how much do ML engineers earn? Junior up to 12 months can earn like 110,000 in a year. Middle from 12 to 24 months, 140,000 in a year. And senior 24 months and more, 250,000. So it's really nice, and yeah, it's great that you can work in areas that you like. For example, if you like robots from your childhood, you can work with your childhood dream and earn on it really good money. Average base salary is 161,000 per year. So as we see, high one is 247, and the lowest is $105,000 in a year. What you will learn. I will tell a little bit information about our course. If you will have any questions, you can write them in chat, and we will answer on all your questions. But now I will tell a little bit information. Work with various machine learning algorithms. You will know how to do it. As I tell you before, the first one will be lections. Next module, it will be practice, and then you will work on project. Data processing techniques, build predictive models, practical applications. What included? Resume building. That's the main thing, one of the main things, because okay, you finish course, and what to do next? How to find a work? We help you with it. You will learn how to create a professional, impactful resume tailored for ICE developer roles, highlighting your skills, projects, and achievements. Career coaching. You will participate in mock interviews and receive personalized feedback to improve your technical and behavioral interviewer skills. We will help you to training the skills. Job search strategies. You'll gain access to job search resources, including how to find job openings, networking tips, and leveraging LinkedIn for job hunting. Because as you know, of course you know, LinkedIn is the main platform to find a job. We will help you to make it better and to help you find a work faster. Timeline of activities. At February 3rd, we will start our course, start our 6-month journey towards a successful career in machine learning. Participate in live sessions 3 times in a week, receiving guidance along the way. It will be learn and practice. Internship. You'll get a real-world experience for your resume. That's what I tell about that we will help you. Career coaching. You'll improve your online presence and prepare for oncoming job interviews. Training program. Introduction to data science. Linear regression and introduction to Sklearn library. Introduction to machine learning. Key nearest neighbors and cross-validation. Stock market prediction. Stock price and volatility forecasting, principal components analysis and regression, k-means clustering, classification, 3-based methods, prediction students loan payment, data cleaning, support vector machines, neural networks, additional programming topics, and natural language processing and large language models. So as you see, we have really huge program, and you will have really good degree after you finish our course. So invest in your future. The base of machine learning is Python language. I think that many people know Python as a base or know Python base, and if you don't know it, now it costs like $999. It will be 4 weeks, and for 4 weeks you will know everything about Python. So machine learning course, now it costs $11,999. But now what we offer? We offer for you to pay $6,999, and then after you will find a job, you can pay another money. What's next? This is a QR code, and if you dive into machine learning with our special offer, you will have a discount, as you see. But it's a limited And if you want to buy it now, you can have this discount. And also, the number of students in the group is limited because our main goal is to make a professional AI programmers. Because you know that now it's too much people on market who really work as well, and our main goal is to make professional. We want to teach you how to work in ML more easier and faster, and really grows as a professional. So this is a QR code for a special offer. And also, if you need any consultation, if you have any questions, you can scan this QR and we will answer on all your questions. Also, you can write to us. Maybe I was talking with someone of you before, and if you have any questions, you can write us and we will answer on all your questions.
Yana, actually, I'm so sorry for the interruption. Hey, Paul, could you please help us with a great question? What is the level of math our students must have?
So I actually just provided a Perplexity automatically generated page on that, just sort of showing cited examples of how, one of them being Perplexity is one of the, but how beginners can make great use of these machine learning tools, all the way up to Terence Tao, one of the most famous mathematicians alive. He compared GPT 01 to a not entirely incompetent grad student in math. So, which I think is saying something pretty, I mean, it's the way he was using the tool that really, you know, where the secret sauce came from. But I mean, it's, if he's able to use it, and then my mom's able to use it, everyone's able to use it with all levels of mathematical ability. It's the whole spectrum. And this course in particular, it looks like a beginner could really benefit from it as well.
Paul, thank you so much for the details.
Yeah, thank you, because I don't see messages in chat. Something was wrong. Thank you, Rina. You help us today. Perfect. Okay, so thank you that you invite our webinar, and we so happy that you visited. Hope I will see you again, and we will make our dreams come true together. So thank you for this webinar, and have a nice evening.